The topic is what? Theorems. In this first theorem is superposition theorem. Superposition theorem. What this superposition theorem states that? What the superposition theorem states that? Any linear active bilateral network contains two or more sources. The network contains two or more sources. The response of the any element in that network can be calculated by applying individual sources separately. Finally, resultant response we have to take it into the account for the response. The overall response in a given network is equal to the sum of individual responses obtained separately. Sum of individual responses obtained separately. This theorem is applicable only when two or more sources are available. When single source is available, you need not apply superposition theorem. Have you got my point or not? So, what is the definition? A linear active bilateral network contains two or more sources. The response of the any element is equal to the sum of individual responses obtained separately by applying individual sources separately. For example, this is a one network. This is a one network. For this network, there is a one voltage source is here. And another voltage source is here. One current source is here. There are three sources. There are three sources. Suppose I want to find the response. Response means output. Input means excitation. Response means output. For example, there is a resistor here. I want to calculate the what is the voltage across this resistor. What is the voltage across resistor? During this condition, you can apply one voltage source. You apply this voltage source. At the time, make these two sources are inactive. Make these two sources are inactive. And see what is the response because of this voltage source. Similarly, apply the second voltage source here. During this condition, make this source is inactive and this source is inactive. Similarly, if you apply this voltage source during that point of excitation, remaining all these two sources made inactive. Whatever the response due to this source, what is the response due to this source, what is the response due to this source, all individual responses combined together will give the resultant response in this network element. Have you got my point? So what is the definition I told you? Write down the notes. Superposition theorem states that in any linear active bilateral network contains two or more sources. The response of the in any element in the network is equal to the sum of individual responses obtained separately. Are you clear? Are you clear or not? Now, what is the important condition is, suppose if you want to apply the superposition theorem, this is a one network. The superposition theorem must obey the condition of linearity and homogeneity. linearity and homogeneity. Superposition theorem must satisfy the condition of linearity and homogeneity. Sir, what is linearity, sir? What is homogeneity? What is linearity? Suppose if I give a excitation for this network with some x, I given a excitation with some x. Suppose at the time I got a response of y. That response may be current or voltage, not be a problem. We are given some excitation, nothing but input. We got some response of y. Whenever if it is multiplied with some constant of k, our output results is also obtained with the same factor. Then it satisfies the linearity condition. Whenever homogeneity means it must satisfy the condition of additivity also. Additivity means if I given a x1 here, I got y1 is here. X1 here, y1 is here. Suppose this is the network. What I can give here? Suppose if I give x2 here, I got y2 here. For the same network, this is the network, x1 is given, I got y1, x2 is given, y2 I got. For the same network, combinedly together, if x1 and x2 is given, suppose if my response is y1 plus y2 obtained, then it is satisfy the additive property. So once if it is satisfy the additive property, it satisfy the homogeneity also as well as linearity also. So once superposition theorem must satisfy the linearity as well as additive property, then only we can apply the superposition theorem. Hello? Video audio quality is fine? Right. Okay. So, superposition theorem must satisfy the condition of linearity as well as homogeneity. Sir, what is the difficulty in the superposition theorem? What is the difficulty in the superposition theorem? What is the problem for the superposition theorem? Have you taken all these things? Superposition theorem is not applicable. Superposition theorem is not applicable to determine, to find the resultant power directly. We can calculate power, but not directly. Because power is a nonlinear function of current and voltage. Power is a nonlinear function of voltage and current. For example, if I give a I1 is here, suppose if I give a I1 here, due to I1 I got some response. If I give a I2 here, due to this I2 I got a response. What is the resultant? If you are giving resultant, what happened? I1 plus I2 whole square into R is equal to P1 plus P2. Is 2 are equal? These two are equal. I1 plus I2 whole square means what? I1 square R plus I2 square R plus 2 I1 I2 R. This is not equal to the I1 square R plus I2 square R. These two are not equal. Then how can you calculate the resultant power? Directly resultant power cannot be calculated. That is most important point. The superposition theorem is not applicable to determine resultant current, resultant voltage, resultant power. Resultant power cannot be calculated directly by using a superposition theorem. Okay? Right. Now, this is what. But what is the resultant power formula? For example, due to I1, some power is there. Due to I2, some power is there. Then what happened? For example, due to I1, I got power of I1 square into R. Due to I2, I got power of I2 square R. I2 square R. So how to get the resultant power? Resultant power P is equal to, generally what is the power formula? P is equal to I square R. For example, P1 is equal to I1 square R. P2 is equal to I2 square R. From this, suppose I want to calculate I1. I1 is equal to, how can I write? Root of P1 by R. I2 is equal to what? Root of P2 by R. Root of P2 by R. How can I get the resultant current? How can I get the resultant current? I1 plus I2 whole square into R is equal to root of P1 plus or minus root of P2 divided by R whole square into R. This is root. This one gets cancelled. What is remaining is resultant power is equal to root of P1 plus root of P2 whole square. This is the resultant total power PT is equal to. You cannot write the resultant power PT is equal to P1 plus P2 whole square. This is wrong. This is wrong. Whenever if the powers are available separately, the resultant power can be obtained by using this formula. This formula. For this I explained how you return. This is the most important concept. Hello? Is it clear what I told you? What I told you clear for you? Right. Whenever if the powers are given separately, if you want to calculate resultant power, root of P1 plus P2, root of P1 plus or minus, depending upon the how they are in aiding or opposing, this is what we have. So superposition theorem is valid to determine current. Superposition theorem is valid to determine voltage. Superposition theorem is not valid to determine power directly. Power can be calculated by calculating either resultant voltage or resultant current. That is only the point. That is only the point. So it must satisfy the condition of homogeneity as well as simply additive and linearity. Linearity property as well as additive property, that we can say linearity and homogeneity. This is very, very, very important theorem. So when this theorem is required, the network contains two or more sources. Sir, I have a small question. Suppose two different frequencies are there. Is it possible to apply the superposition theorem? Is it possible to apply the superposition theorem? No problem. Even if the frequency excitations are different, corresponding impedances we have to calculate. No problem for the application of the superposition theorem, even if the sources contains two different frequencies. That is important point. And sir, while applying the superposition theorem, suppose if the circuit contains the dependent sources, we can apply the superposition theorem. It is applicable or not? Superposition theorem is applied even if the dependent sources are present in the network. But the condition is the dependent sources should be a linear dependent. Non-linear dependent sources. Because the basic statement is what? The linear active bilateral network containing two or more sources. The response of the element is calculated. Like that we have. Linear and homogeneity. That is what. Dependent sources are there. We can apply superposition theorem. But those dependent sources should be a linear dependent sources. Now, a small question I will give for you. This is the one network using SPT, using superposition theorem. Find Vx. This is what the circuit. Sir, one important point. Keep it in mind. This is the very, very important point. Suppose if the network containing voltage source. Sometimes we want to make the voltage source should be 0. How can you make the voltage source is 0? By shorting the terminals. Voltage source should be shorted. But if any internal sources is present in the voltage source, we have to replace the internal source as resistance as usual. Even though if it is a voltage source or current source, by making voltage and current sources, the internal resistance should be included as it is. We should not make those values are 0 or infinity. I hope you understand. If any internal sources are there, we have to keep the internal source even if making the voltage source and current sources are 0. Resistance you cannot make 0. That is the point. Now, this is having 20 volts. This one is 10 amperes. It is 20 ohms, 50 ohms, 10 ohms, plus and minus Vx we have to take. Vx. Now, find the Vx for this. Using what? Superposition theorem. We can solve the same problem by using nodal analysis also. That is more convenient. But for the purpose of practice, I am giving. Apply the superposition theorem. Now, for this first case, if you apply this voltage source, make this current source is 0. Make this current source is 0. So what is the voltage Vx here? What is the voltage Vx here? 20 into 50 divided by 70. Potential divider formula. These two are the series resistors. 20 into 50 divided by 70. 100 by 70. 10 by 7. 10 by 7 volts. 10 by 7 volts. Due to this 20 volt source. And again what we have to apply? We have to apply this current source. We have to apply this current source and make this voltage source is 0. Because one source is given, other source is inactive. This source is given, this source should be inactive. Like that we have to apply. So what is the current here? 10 amperes. 10 amperes is coming here. What is the current here and current here? Apply current divider formula. 10 into opposite resistance. 20 divided by total resistance. 70. 200 divided by 70. 200 divided by 70. But what do you want? We want the voltage. This is the current only. This is the current due to this one. How can you get that voltage? How to get that voltage? Current into resistance. So 50 into 200 divided by 70. 200 divided by 70. This is 100 divided by 70. 100 divided by 70 plus 1000. 10,000. This one is 10,000. 10,000 divided by 70. That is the total V. Total V. Okay? Is it clear, all of you? Find the VAB. Find the VAB in the given network. Find the VAB in the given network. This is the problem we have. 2 at an angle of 0. This is I1. This is I1 is here. And this is I2. I2 is equal to 4 at an angle of 0. I2 is living here. I1 is living here. I2 is living here. This is 5 ohms. This is 10 ohms. This is 2 ohms. This is A. This is B. We want to find the VAB. This is very simple problem. See, apply this current source. Apply this current source Under that condition, you try to make the source is inactive. Source is inactive. Once if you make inactive, some current is here, 2 amperes. Current is flowing like this, current is flowing like this. One current is coming here, other current is coming here. How these two are is in series. So what is our circuit become like? What is our circuit becomes like? This is 2 ohms and this is 15 ohms. 15 ohms. And this is 2 amperes. Now we want to find the current passes through 2. Nothing but current divider formula you can apply. 2 into opposite resistance. 15 divided by 17. 30 divided by 17. 30 divided by 17. So 30 divided by 17 is the current. Voltage means you have to multiply with 2 because voltage you need. 60 divided by 17. 60 divided by 17. Similarly, for the same problem, you can make this is 0. You can make this is 0. Second one, you can apply the current here. This is the current here, 4 amperes. Where you need voltage across this one, you need. Voltage across this one means current divider formula again we have to apply. What is the current divider formula? 4 into, for this you need this current. Opposite resistance is 10 divided by 10 plus 7, 17. That is 40 by 17. 40 by 17. What about this drop here? Into 2. 80 divided by 17. So, due to this voltage, due to this current, due to this 2 amperes, this is the response. Due to this 4 amperes, this is the response. So, resultant voltage. Resultant voltage. How can you get the resultant voltage? Yes. Resultant voltage is 80 divided by 17 plus 60 divided by 17. 140 divided by 17. That is the answer.